What's happening beneath Mount St. Helens? Seismic activity is surging, raising fears of an impending eruption. Hey everyone, welcome back to our channel. Today, we're diving into some intense updates about one of the most famous volcanoes in the United States, Mount St. Helens. This iconic stratovolcano is rumbling more than ever, and we're here to break down what that means. Significant seismic activity has been detected beneath Mount St. Helens, a volcano that typically experiences about 11 minor tremors per week. Recently, this number has spiked to an average of 35 quakes per week. The U.S. Geological Survey attributes this increase to the movement of magma beneath the surface. But what triggers such rapid escalation in volcanic unrest? Is this current level of activity a sign of a looming eruption? Join us as we explore these unfolding events. Since February this year, Mount St. Helens has recorded 1,368 small earthquakes. Most of these quakes were less than magnitude 1. Too small to be felt at the surface, occurring at a median depth of around 3.5 miles below sea level. The largest recorded earthquake was a magnitude 2 in May, with a peak of 38 earthquakes in a week in early June. The USGS believes that this elevated seismic activity could indicate the volcano is going through a process called recharge, involving the arrival of additional magma. While the risk of eruption has increased, Mount St. Helens remains a fascinating and active stratovolcano in Skamania County, Washington. Mount St. Helens is part of the Cascade Volcanic Arc, a segment of the Pacific Ring of Fire. Situated 34 miles west of Mount Adams in the western Cascade Range. Often referred to as brother and sister mountains due to their proximity and volcanic nature, these two are about 50 miles from Mount Rainier, the tallest of the Cascade volcanoes. To the southeast, you'll find Mount Hood, another major volcanic peak in Oregon, 60 miles away from Mount St. Helens. Unlike its older siblings, Mount St. Helens is geologically young, having formed in the past 40,000 years. Its summit cone, which existed before the 1980 eruption, began to rise about 2,200 years ago. Among the Cascade volcanoes, Mount St. Helens is the most active, especially within the Holocene epoch, which covers the last 10,000 years. Imagine standing before what was once the fifth highest peak in Washington. Often compared to Japan's Mount Fuji, earning it the nickname Fuji-san of America for its striking symmetry and extensive snow and ice cover. Before the 1980 eruption, Mount St. Helens was a majestic 5,000 feet taller than its base, with its lower slopes blending seamlessly into the nearby ridges. At the bottom, the mountain spanned 6 miles across, resting at an elevation of about 4,400 feet on the northeastern side and 4,000 feet elsewhere. The mountain's ice cover included 11 named glaciers. After the eruption, only the Shriner Glacier showed signs of revival. Streams originating from Mount St. Helens feed into three main rivers, the Toutle River to the north and northwest, the Cowlitz River to the west, and the Lewis River to the south and east. These streams are nourished by substantial rain and snow, with an average annual rainfall of 140 inches and snowpacks on the upper slopes reaching up to 16 feet. The Lewis River plays a crucial role in hydroelectric power generation, with 3 dams harnessing its flow. The southern and eastern sides of the volcano drain into the Swift Reservoir, located just south of the peak. Let's talk about the fascinating crater glacier, which began forming during the winter of 1980-1981. Originally called the Tulutzen Glacier, this ice giant expanded rapidly, thickening by about 14 feet each year. By 2004, Crater Glacier spanned approximately 0.36 square miles and was split into western and eastern sections by a volcanic dome. By late summer, the glacier often appeared dark due to rockfall from the crater walls and ash from volcanic eruptions. Starting in 2004, volcanic activity began reshaping the glacier, pushing its lobes aside and causing new volcanic domes to form. This upheaval transformed the glacier surface into a chaotic landscape of icefalls, crevasses, and seracs. By late May 2008, the two lobes had rejoined, completely encircling the lava domes. Since 2004, new glaciers have formed on the crater walls above Crater Glacier, adding more rock and ice to its surface. Mount St. Helens is part of the Cascades Volcanic Province, an arc-shaped region stretching from southwestern British Columbia to northern California. This area is fascinating due to the geological process called subduction, where a dense oceanic plate sinks beneath the North American plate. As this oceanic slab sinks deep into the Earth, high temperatures and pressures cause water molecules trapped in the minerals to escape. This superheated water rises into the flexible mantle above, leading to some of it melting. This newly formed magma starts moving upwards through the crust, finding its way through fractures and faults, and even melting some of the surrounding rock. Beneath Mount St. Helens, magma has accumulated in two chambers. The upper chamber lies about 3 to 7 miles below the surface, while the lower chamber is deeper, about 7 to 25 miles down. This lower chamber might even be connected to Mount Adams and the Indian Heaven volcanic field. Mount St. Helens, one of the most active volcanoes in the United States, has a rich and complex history of eruptions that can be categorized into distinct stages. These stages mark significant periods of volcanic activity, each characterized by unique geological events and lava formations. The earliest recognized stage is the Ape Canyon stage, which occurred approximately 40,000 to 35,000 years ago. During this time, Mount St. Helens experienced a series of explosive eruptions. These early eruptions contributed significantly to the formation of the mountain's initial structure. The volcanic activity during the Ape Canyon stage was marked by the ejection of large amounts of tephra, a mixture of volcanic ash, rock fragments, and gas that is expelled during an eruption. This stage laid the foundation for the complex stratovolcano that Mount St. Helens would eventually become. Following the Ape Canyon stage was the Cougar stage, which took place around 20,000 to 18,000 years ago. This period was also characterized by significant volcanic activity, including powerful explosive eruptions. The Cougar stage is notable for the extensive lava flows and pyroclastic flows that reshaped the landscape around the volcano. These flows deposited large amounts of volcanic material, contributing to the growing mass and height of Mount St. Helens. The eruptions during this stage played a crucial role in building up the volcanic edifice and adding layers to its structure. The next major period of volcanic activity is known as the Swift Creek stage, which occurred roughly between 13,000 and 8,000 years ago. During this stage, Mount St. Helens continued to experience frequent eruptions, although the nature of these eruptions varied. Some were explosive, producing vast amounts of ash and pyroclastic material, while others were more effusive, resulting in the flow of lava that further shaped the volcano's profile. The Swift Creek stage was instrumental in the continued development and evolution of Mount St. Helens, as each eruption added new layers to its complex geological structure. In summary, the eruptions of Mount St. Helens are categorized into distinct stages: the Ape Canyon stage, the Cougar stage, the Swift Creek stage, and the current Spirit Lake stage. Each of these stages represents a significant period in the volcano's history, marked by unique volcanic activities that have shaped and reshaped the mountain over tens of thousands of years. Mount St. Helens continues to captivate scientists and the public alike with its dynamic volcanic activity. While the risk of eruption is present, the ongoing studies and monitoring help us understand and prepare for any potential events. Stay tuned to our channel for more updates on this and other fascinating natural phenomena. Don't forget to like, subscribe, and hit the bell icon to stay informed. Thanks for watching.